All right, hey class, welcome to an episode of Brand Academy. As always, my name is Brand. I'm Mr. Wynn's twin brother. And today, we'll be talking about chapter 10.3, Operation with Radicals. I know before we're talking about chapter 8, we're just doing this one little section to combine it with chapter 8 because it just kind of fits well with like terms, because today we're doing something called like radicals, okay? So again, please print out these notes or take your notebooks out to write everything down. Two radicals that have the same radicand. So remember, radicand is just the inside part of the radical. Like here, radical 7, this is what we call the radicand. Radicand. Okay. So two radicals that have the same radicand are like radicals. Boom. So for example, look at all these here. 4 radical 3, negative 3 radical 3, radical 3, 5 radical 3 are all like radicals, okay? 2 radical 5 and 3 radical 7 are not like radicals, okay? So the cool part is that like terms and like radicals, you do exactly the same thing when you add or subtract them. So again, in order to add or subtract radicals, they must be like radicals. So in this case here, radical 2 plus radical 3, we could simplify this. Fun fact, that invisible number here is 1 radical 2 plus 3 radical 2. That will get you 4 radical 2. Easy, right? And so again, this here is just very similar if I did like 1x plus 3x, right? If I did 1x plus 3x, it's the same as 1 radical 2 plus 3 radical 2. But instead of the radical 2, right, I have the x. So in this case, this would be 4x. Okay, just a side example. Radical 10 minus 5 radical 10. Again, same drill. You have the 1 in front. Minus 5 radical 10. Thus, negative 4 radical 10. Okay, easy peasy. Oh, check this out. Simplify 7 radical 3 minus radical 12. So these are not like radicals. So what you have to do is simplify first. So in this case, radical 12, we should know how to simplify this. Two numbers, 4 and 3. 4 is that perfect square. Circle it. What's the square root of 4? Remember, the circle means the number goes outside. So 2 radical 3. I'll probably keep this in red. 2 radical 3. Now this is more doable. Okay, 7 and 2 is 5. And then you just keep that like radical 3. Okay. Boom. All right. Now we're going to practice using distributive property with this. Radical 3 times the quantity radical 6 plus 7. Okay, you do it to each number. Radical 3 times radical 6, radical 18. Plus 7 times radical 3, right? You simply just put this number, you put the 7 in front of that radical 3. Okay, so kind of absorb that step there. Again, radical 3 times radical 6 is radical 18. And radical 7, and then radical 3 times radical 3 times 7 is just 7 radical 3. Okay, you don't multiply them together. It's not 21, right? Because this is a radical and this is just a constant. Okay, it's just a whole number. So now radical 18, you could break this down. 9 and 2. 9 is a perfect square. So 3 radical 2 plus 7 radical 3. Can I add these right now? Look at it. Are they like radicals? Okay, these two are not like radicals. So if they are not like radicals, you simply stop there, and that is your final answer. All right, let's try this one here on your own. Oh, that's strange. I feel like this here is a mistake. You guys ignore this one. Okay, scratch this example. You're going to do this example instead. Radical 5 times 3 minus radical 15. So try this here, okay? Why don't you guys just try this on your own real quick, okay? So hit pause here and try this one on your own. Alright guys, kind of check the answers here, okay? So you're going to multiply radical 5 times 3. That's 3 radical 5. And over here, you're going to do radical 5 times radical 15. Oh, keep in mind is negative radical 15. So that would be negative radical 75. Okay, and then again, see if you can break this down here. 75, okay, so think like your quarters, right? 25 cents, 50 cents, 75 cents, so 25 and 3. Turns out 25 is a perfect square. The square root of 25 is 5. You're left with the radical 3. And over here is still your 3 radical 5. Make sure there's a minus sign here. Can you simplify this? The answer is no. Okay, yeah, radical 5 and radical 3. Those are not like radicals. Okay, so you stop there. And again, not like radicals. Okay? Alright, good job there. Okay, good luck with your homework, and I'll see you guys Thursday. Thursday or Friday, I guess.